Hey everybody, Mike Lukic here from Solver School, and welcome back to the Solver School YouTube channel. I decided to start releasing a new series of videos that I'm calling Solver Shorts. I often get asked very specific questions about Solver functionality that doesn't necessarily take a full 45 minutes or an hour like all of my other videos to answer, but nevertheless are important concepts to understand as you work in solvers. So I've decided to create some smaller bite-sized 5 to 10 minute videos that really answer some of these very pointed questions and start releasing them a little bit more frequently on this YouTube channel. Now, all of this material is available within my Solver Masterclass course. So if you do like the content that you see here and you're interested in learning more, check out my website at www.solver.school for more information about the Solver Masterclass. Or you can also make sure that you subscribe to this YouTube channel to get notified whenever new Solver short videos are released. But now let's actually just jump into this particular week's Solver short video where I'm going to look at the bet sizing syntax that's available to you as you're setting up your game trees within PioSolver. Within this video, I'm going to be jumping back and forth between a PowerPoint slide where I go through the various options and the examples within the PioSolver interface itself. So let's hop over into the slides and start looking into the different options and take a look at the examples within PioSolver. So there are a number of different ways in which you can enter bet sizes into the free text boxes within PioSolver. And we're going to go through all of those different options here within the PowerPoint slides. After I introduce one of these options, I'll then switch over into PioSolver just to show you an example of how that actually works within the user interface. We'll start with the method that you're probably most familiar, and that's just entering a plain number or a numeric value. And whatever number that you enter, it represents a percent of the pot. Now you can enter one value, so I have here this number 33 that is in here, and that's going to represent one bet of 33% size of the pot. You could also enter multiple values, separating each of the values by a comma, and that's going to give you multiple bet sizes based on how many that you actually enter. So if I enter 33, 80, that's going to give me two bet options where I have an option of betting 33% of the pot and 80% of the pot. So let's hop over in PioSolver and quickly show you how this numeric option works and what you actually get when you build out the game tree within PioSolver. All right, so here in PioSolver, the simplest example is this first numeric example. And as I mentioned here, you can just type in some numbers here. So I've typed in 33 and 80 for both the in position and out of position players. We'll use the same scenario for all of these examples, but it's an in position under the gun open versus a big blind defend with starting pots of 100 and effective stacks of 1,000. So we'd expect to see at 33 and 80 bets of 33 chips and 80 chips because that's based off of a 100 chip pot. 33% and 80% is just that same number of chips. And as I go to the browser, we can see that the out of position has two options for 33 and 80. The in position has two options for 33 and 80. If I were to change this pot size to 200 and rebuild this tree, we can see that the bet sizes change, but the percentages stay the same here. So it's that 33%, which is 66 chips, and 80%, which is 160 chips for both of these players. The raise sizes actually work the same way too, off of a number standpoint. So I will open up the second option I have here. So I've added 100 as the raise size, and if we go to the browser here, if we click on this bet 33 option, now the pot size is 133. So after adding the 33 in for calling, that brings the pot size up to 166. And 166 plus the 33 is a raise to 199. So that's the way the raise sizes works here by adding 100%. Now the next value that we have is this all-in or A. And it's very specific with the formatting here. So you can either type ALLIN for all-in, or you can type A. And simply what that's going to do is that's going to add a bet or a raise for all of the remaining chips. Now, it's important to note that this is not the equivalent of including the add all-in checkbox. If I add the all-in checkbox, what that is going to be constricted to is it's going to be limited to some of the other options that you might have in the game tree. So there's actually another option in there where it will only add an all-in if the effective stacks are a certain size as it relates to the size of the pot. This adding an A or adding an all-in will add an all-in value or an all-in bet size no matter what the size of the pot is. So let's just jump over into PioSolver and I'll show you how that works. The all-in structure is fairly easy, and you can see both options here work. You could have the A or you can have all-in. Now, as I mentioned in the slides, there's this option here for clicking this box for add all-in. I can add all-in, but it's going to be limited to these constraints as well too. So there's an all-in threshold. There's also an add all-in only if it's less than 500% of the pot. Whereas these adding an A and adding all-in, they're going to add an all-in no matter what. So when I hit the browser, it's going to give the option here for the 33% bet, the 80% bet, and an all-in. So you can see here, bet 33, bet 80, and then bet 1,000 for all in. So that's how you would utilize the all in functionality when you're building game trees. Now the next option that we have is adding a number and then the letter C, where, and I have here as this example XC, where X is a number, but this could be 40C, 100C, whatever values that you actually want, where a number is preceding the letter C. Now what this is going to represent is a bet or a raise by whatever number that you chose chips. Now, it's one thing to note here is that you're going to have to be very specific with the betting units that you choose when you set up the game tree. So if you're choosing to look at things in big blinds, whatever number that you allocate here, you have to be consistent with those units. If you choose to set up your game tree in chips, then you're obviously going to have a lot larger of a number here than you would if you chose to model things in terms of big blinds. This option isn't something that you utilize a ton in no limit games, but this is actually very, very useful to model limit games. So let's hop over into PioSolver. I think this is one of those concepts that's a little easier to understand when you actually see how this operates within the user interface. So we'll hop over into Pio and I'll show you how this works. The chipped options, it's really only useful for you when you are building out limit game trees, but actually it can be really, really good to use a tool like PioSolver to solve limit streets if you'd like to. So I have a good mix here. So the add position, I still have this 33 to 80% pot sizings, but what I've done here is I've added bet sizes and raid sizes for the in-position player as 100C and 50C. So when we look at this, we can see that we still have these different bet sizes, or the variable bet sizes, which are based off the percent of the pot from our previous example. But if I check, then the in-position player can only bet 50. And off of any bets, the raises are only raises in increments of 100. So you can see it's just adding 100 chips each time. Again, good for limit, not so much realistic for no limit. But the option is there if you do want to model something where you are including a very finite number and you want to add that as a branch of the game tree. The next value here is where you are adding a raise size as a multiplier of the previous bet. And the format here is I have it as YX, where Y is a number. Again, same thing as previously. It doesn't matter what number you choose, you just have to use the letter X after it. And what that's going to represent is a raise amount for Y times the previous bet. So commonly used here would be 3x, 4x, 2x, whatever the case may be. But if I chose 3x here, that's going to choose a raise size that is going to equal 3 times the size of the previous bet by whoever that player's opponent is on the previous street. So let's hop over into PioSolver and show you how this works. The raise x times the previous bet is used fairly often, but I actually think it's somewhat of a flawed methodology. And actually, I tend to recommend that you use percentages and not this x. Main reason being is sometimes it doesn't elicit the most realistic responses. So we've all been in this scenario where we get to a pot and maybe the pot size here is 10 big blinds and somebody just donk leads out with 1 big blind. Well, if we were choosing this raise size of 3x, it would essentially just give a raise to 3 big blinds off of, even though the pot size is 10 big blinds, and that's somewhat unrealistic. So, but you can use this functionality in here, and it does. It's useful if people are betting normal sizes. Again, as I mentioned before, it's going to raise 3 times the previous bet size. So if we go and take this bet size of 33, the raise 3x will bring it up to 99. If I bet 80, the raise 3x will bring it up to 240, and so on and so forth. So it's taking the previous size bet and it is raising that multiple of the amounts that you chose. So by choosing 3x, it's choosing a multiple of 3 times that previous sizing. The last option here, which is a little complicated, but I think it's one of the most useful ones, is adding the letter E. And the format that I have here is NE, where N is equal to a number. This is going to represent a split of the effective stacks into N equal bets. It's often referred to as betting a geometric sizing or aligning things to the geometric growth of the pot. Sometimes it can be useful to think about betting a same percentage of the pot for 2 streets or 3 streets to ensure that you are all in by the time you get to the river. And that's where this geometric sizing can come into effect. So I have this example here on the slides. If the pot is 100 and the effective stacks are 1,000, if I wanted to split the remaining bets into 3 equal bet sizes as it relates to the size of the pot, that would actually equal 3 separate 87% pot bets. If I wanted to do it over 2 bet sizes over the remaining 2 streets, it would be 179% pot across those 2 streets. Again, it helps make sure that you are keeping consistent sizings as it relates to the overall size of the pot. Now, with this formatting, you can actually also add a number after the E. So you can have this Z value here, where Z is also a number to indicate a maximum bet size. So maybe I chose 3E200. What that's going to do is it's going to choose things in geometric sizings, but it's also going to add a maximum value, and that 200 will be the maximum value that it will choose regardless of what the geometric bet sizing looked like there. Now, you don't need to understand this formula, but if you do actually want this, the geometric bet size formula is going to be equal to this formula here, where you have a pot size and your effective stack size, and then this number of bets equals how many streets that are left within the hand that you actually want to split those bet sizes across. So let's hop over into PioSolver and we can take a look at the geometric bet sizing options. Now, the geometric sizing, I think, is pretty cool to utilize, especially when you're trying to estimate in-game, trying to get to a point where you are running the same size bets relative to the size of the pot on multiple streets. And when you're planning that bet sizing out across multiple streets, you have the option of using, for the most part, we usually use it from a 3E or 2E perspective. So you might choose 3E when you're on the flop and you want those 3 bets to be equal in relation to the size of the pot. up until the river. On the turn, you can use 2E to get to the river that way. You really wouldn't use E on the river here. I have it here as an example, but by the time you get to the river, you would just choose all it. The way to visualize this, though, and you can kind of see from the browser, if I choose and this is the in-position player that I've chosen to do this with, so I am checking. The in-position player has the option here to bet 88% of the pot, which, as we've discussed, the 3E off of this 1,000 stack is 87.xxx%, 87 and change. So it's 88% of the pot. 88 chips here is the actual bet for the in-position player. If he is called, he gets to the turn, and after the check, it's now 243, which is this 88% of the pot again. And then when we get to the river, after a check, the bet is 669, which is the remaining amount of the stack, which again is going to be 87% of the pot. So it's splitting those bets out equally over the course of the entire streets. We can check to get to the turn, and as I put 2E on the turn, so as we check to get to the turn, now the option is betting 179 into 100, because to get all of the chips in with 2 streets left, we now have to bet 1.79x pots for 2 streets to get all of the money in. And that's how the geometric size works. If you're looking for reference for all of this, you can actually click this selecting bet sizes, and it's going to bring up this option which will give you a little bit more detail about how to use each of these pieces of functionality. But this is a nice quick way to show you how to utilize the different syntax within PioSolver. Well, that does it for today's Solver Short. Don't forget to subscribe to the channel to be notified when the next Solver Short video comes out. And for more information and Solver content, make sure you check out the Solver Masterclass at www.solver.school. I have over 30 hours of video content specifically designed to teach you how to use solvers properly within your own game. Thanks again, and I'll see you next time.